Hello 9th grade students, how are you? I hope you guys stay healthy and stay passionate to study physics. Now we will continue our learning section on the topic of the atomic structure, and especially through the video we will learn about the history of the atomic theory. The basic competence of this material is to connect the concept of material particles, atoms, ions, molecules, and the structure of the simple substances to the properties of the material that used in daily life and the effect of their use on human health. The first scientist was Democritus. Democritus was the first person to come up with the idea of the atom. Believed that all matter was composed of indivisible particles he called atoms, which is derived from Greek word atomos. The meaning is indivisible. He also believed that different atoms are different sizes, have different properties. Other philosophers of that time didn't agree with his theories. The second scientist is John Dalton. Dalton is the father of atomic theory. Dalton's ideas were so brilliant that they have remained essentially intact up to the present time and has only been slightly corrected. 5 postulates Dalton's atomic theory. Number 1. All matter is composed of extremely small particles called atom. He is agree with Democritus. Number 2. All atoms of a given element are identical, having the same size, the same mass, and the same chemical properties. Number 3. All atoms of different elements are different. Number 4. Atom cannot be created, divided into smaller particles, or destroyed. In a chemical reaction, atoms of different elements are separated, joined, or arranged. They are never changed into the atom of another element. We will learn more later. And number 5. Atoms combine in indefinite whole number ratios to make compound. You can have a half of a carbon bonding with oxygen. It's a whole atom or no atom. Next, Dalton's atomic model. Based on Dalton's atomic theory, 5 postulates, most scientists in the 1800s believed that the atom was like a tiny solid ball that could not be broken up into parts. Dalton was credited for the 3 atomic laws that were proven after his time. Dalton's atomic laws. Number 1. The law of conservation of mass. Matter cannot be created or destroyed in any physical or chemical process, just transferred. Number 2. The law of constant composition. When atoms combine to form molecules, the ratio of the atom is constant. For example, H2O will always have 2 times of as many hydrogen atoms as oxygen. Number 3. The law of multiple proportion. If 2 elements can combine to form more than one compound, then the ratio of the second element combined with a certain mass of the first element is always a ratio of a small whole numbers. For example, the ratio of NO. The number of mass of N is 14, the number of mass of O is 16. So the ratio of NO is 14 over 16. And the simple ratio is 1 over 1. Next, NO2. The number of mass of N is 14 and the number of mass of O2 is 32. So the ratio of NO in NO2 is 14 over 32 and the simple ratio is 1 over 2. Next, the law of conservation of mass. When a chemical reaction occurs, mass is neither created or destroyed but only changed. The third scientist is J.J. Thomson. J.J. Thomson used cathode rays to prove that Dalton's solid ball model could be broken into smaller particles. Thomson is credited with discovering electrons. Cathode ray tubes. Cathode ray had been used for some time before Thomson's experiments. A cathode ray is a tube that has a piece of metal called an electrode at its end. Its electrode is connected to a power source or battery. When the power is turned on, the electrode becomes charged and produces a stream of charged particles. They travel from cathode across the tube to the anode. Thomson put the tube in a magnetic field, he predicted that the stream would travel in a straight path. Instead, he found that the path curved away from a negatively charged plate and toward a positively charged plate. Why? Like charges repel each other, and objects like unlike charges attract each other. Thomson concluded that the stream of charged particles had electrons in them. This is the illustration of cathode ray tube experiment. From the cathode ray tube experiment, Thomson concluded that the cathode rays are made up of invisible negatively charged particles called the electrons. These electrons had to come from the matter or atoms or of the negative electrode. Since the electrode could be made from a variety of metal, then all atoms must contain the electron. Thomson's plumb pudding model. Thomson's plumb pudding model is a positive charged sphere that has negative charged electrons scattered inside like present in the plum pudding. Overall, the atom is neutral atom because the atom had the same number of positive and negative charges. From Thomson's experiments, scientists concluded that the atoms were not just neutral spheres, but somehow were composed of electrical charged particles. The balance of positive and negative charge support the neutral atom. The first scientist was Rutherford, took Thomson's plumb pudding model and added to it, used the gold foil experiment to discover the existence of an atomic nucleus and proton in later experiments. Gold foil experiments. Rutherford directed a narrow beam of an alpha particle plus charges at a thin piece of gold foil, and based on the observation from the other experiments involving alpha particles, he predicted that the positive charges would go through the foil. And the result from gold foil experiment, Rutherford found that every once in a while, A plus particles was deflected bounced back about 1% of the time. Why? Because the positive charge hit a central mass of positive charge and was repelled. This is the picture of gold foil experiment. This is the illustration of the gold foil experiment. The Rutherford gold foil experiment used an alpha particle gun. This periodically shot heavy, positively charged helium nuclei at the thin gold foil target. Alpha particles that passed through hit the surface of a sensitive detector. Those collisions created bursts of fluorescent light where the particle hit. Most particles passed straight to the thin foil target, and some were madly deflected. But surprisingly, a very few bounced backward toward the particle surge. The result, the majority of the atom is phased, most alpha particles pass right through. But a few hit the very small but very dense and positively charged nucleus. Next, the nuclear model of the atom. To explain the result of the experiment, Rutherford's team proposed a new model of the atom. The conclusions from Rutherford's gold foil experiment. Number 1. The atom contains a positively charged nucleus. Number 2. This nucleus contains almost all of the mass of the atom, but occupies a very small volume of the atom. Number 3. The negatively charged at the electron occupied most of the volume of the atom. Number 4. The atom is mostly empty space. Rutherford's planetary model. To explain his observation, Rutherford developed a new model. The electrons orbit the nucleus like the planet revolve around the sun. The fifth scientist was Niels Bohr. Niels Bohr worked in Rutherford's lab. Wonder why minus electrons are not attracted to the positive nucleus and cluster around it. This proved Rutherford's planetary model, and experimented with light and its interaction with matter to develop a new model. Bohr energy level model. Energy level models say that electrons are arranged in circles around the nucleus. Each circle has different energy. Electrons are in a constant motion, traveling around the circle at the speed of light. Electrons can jump from one circle to the next. but they cannot go to the nucleus, they're traveling too fast to be fully interacted. Bohr's energy level model. He proposed the following. Protons and neutrons are in the nucleus. 2. Electrons can only be certain distances from the nucleus. 3. The electron orbit the nucleus at fixed energy levels. Number 4. The electrons must absorb or emit a fixed amount of energy to travel between these energy levels. Next review. Who is the father of atomic theory? Yes, Dalton. Number 2. What was the first model of the atom? Yes, Dalton's tiny ball model. Number 3. What are Dalton's 3 laws? Yes, the law of conservation of mass, the law of constant composition, and the law of multiple proportion. Next, how were Thomson's and Dalton's model different? Yes, Dalton's model was one sphere that cannot be divided, but Thomson had the plum pudding where electrons are randomly spread throughout a positively charged sphere. What did Thomson find out? Yes, Thomson have electrons, they have a negative charge. What were Rutherford's conclusions from the gold foil experiment? Yes, atom has a positively charged nucleus, electrons are outside, atoms are mostly empty, and nucleus contain most of the mass. That's all for me. Thank you for your attention and God bless you.